Have you ever really stopped to think about your eye color? I mean, really think about it. Because it's so much more than just a feature you see in the mirror. It's actually a story. A story about ancient genetics, some wild physics, and even your personal health. So let's get into it. All right, first up, let's make this personal. I've got a question for you. How rare do you think your eye color actually is? You might be in for a surprise when you see where you land on the global spectrum. Okay, take a look at these numbers. Brown eyes are by far the most common. We're talking nearly 80% of everyone on Earth. It's the default setting, you could say. Blue eyes come in at a distant 10%. But if you have green eyes, wow, you're part of a pretty exclusive club. Just 2% of the entire world's population. So that raises a pretty big question, right? How did they end up with this distribution? Well, believe it or not, it all traces back to a single pigment and a story that starts way, way back in human history. This is kind of mind-blowing. For the vast majority of human history, every single person on the planet had brown eyes. That was it. Then, around 10,000 years ago, something incredible happened. A single, random genetic mutation popped up in one person living near the Black Sea. And that one mutation, it created the very first blue eyes. Think about that. It means every single blue-eyed person alive today is a distant cousin, all tracing back to that one ancestor. So what's the biology behind all this? What's the mechanism that creates all these different colors? Well, the secret isn't that you have, blue or green pigments in your eyes. It's all about how much of one pigment you have. The best way to think about it is like a dimmer switch for a light. And that one pigment is called melanin. You've probably heard of it. It's this dark brown stuff our bodies produce, and its main job is to absorb light. So the more melanin your body makes, the darker your eyes, your hair, and your skin are going to be. This really breaks it down perfectly. If your iris is just jam-packed with melanin, it soaks up almost all the light that hits it. That's what makes your eyes appear dark brown. But if you have very little melanin, something totally different happens. The iris doesn't absorb the light, it scatters it back out. And because blue light waves are shorter, they scatter the most. It's the exact same reason the sky looks blue. Yep, you heard that right. Blue and green eyes have zero blue or green pigment in them. None. Their color is basically a beautiful optical illusion. It's created by physics, by the scattering of light, not by pigment. Pretty wild, huh? Now, let's talk genetics. If you remember anything from your high school biology class, it's probably that brown eyes are dominant and blue eyes are recessive. Well, I hate to be the one to tell you, but it's time for a little update. The real story is way, way more complicated. We were all taught this super simple model, right? The one that says 2 blue-eyed parents can't have a brown-eyed kid. But we now know that's not exactly true. It can happen. So what gives? Because it's not about one single gene. Not even close. Right now, scientists have pinpointed at least 16 different genes that all have a say in determining your final eye color. It's what's called a polygenic trait, which just means multiple genes are all pitching in. So what are all these genes doing? Well, you can think of them as a team of project managers for melanin. They're controlling how much of it gets made, how it gets shipped around, and exactly where it gets stored inside your iris. It's this incredibly complex teamwork that gives us the entire beautiful spectrum of eye colors we see in the world. Okay, so this is all fascinating stuff, but it's not just genetic trivia. The amount of melanin in your eyes, your eye color, actually has some very real-world consequences for your health and can even hint at your risk for certain medical conditions. So, if you have light-colored eyes, do you find yourself constantly squinting in the sun? That's a real thing called photophobia. Since you have less of that light-absorbing melanin pigment, your eyes just can't block out the glare from bright sunlight or even harsh indoor lights as well as brown eyes can. And that lack of pigment can lead to more serious problems down the road. You see, melanin basically acts like a natural, built-in sunscreen for the inside of your eye. When you have less of it, you're just more vulnerable to damage from the sun's UV radiation. And this table really lays it all out. If you have light-colored eyes, you've got a higher risk for UV damage, certain eye cancers, and macular degeneration. But here's where it gets interesting. There's a twist. It seems that people with dark brown eyes actually have a slightly higher risk of developing cataracts. The science on why that is? Well, it's still being figured out. So, When you look at all this health data, it points to one very clear conclusion. Protecting your eyes from the sun is an absolute must, no matter what color they are. And the best part? It's really, really simple to do. And here's another reason why that protection is so important. Get this, your eye color isn't necessarily permanent. While the basics are set when you're a baby, things like a lot of sun exposure over your lifetime can actually cause your eyes to get a little bit darker as your body tries to create more of that protective melanin. The big takeaway here is to make this stuff a habit. It's a simple 3-step plan. First, always wear sunglasses and make sure they say 100% UV protection right on the label. Second, throw on a wide-brimmed hat. It adds a whole other layer of physical shade. And third, just be smart about how much time you're spending in that really intense, direct sunlight, especially in the middle of the day. So the next time you catch a reflection, remember what you're really looking at. Your eye color isn't just a color. It's a direct connection to a single person who lives 10,000 years ago. It's a living example of light physics, and it's a personal roadmap for your health. It's an epic story. So what story do you see in yours?